Hello guys, welcome to Solving Solutions, your number one channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to discuss about zone crossing. Right, good. Now, you know the UTM divides the Earth into 60 zones where each of them is 6-degree longitude wide. Right, good. So we have this file here visualized on QGIS that shows the 60 zones. You can see from zone 1 to zone 60. Now this is a concept in map projection that helps understand how the round surface of the earth can be projected on a flat surface just like this. Right, good. So you know, when you're trying to project, there will be distortions. So there are some things that you just let go, maybe shape, area, they call them distortions. So we have actually projected the curved surface of the earth on a plane surface, and then the projection is the universal traverse Mercator, which is the system that was used. Now we have 60 zones, zone 1 to 60, where each of them is 6-degree longitude wide. Right, good. Now each of the zone has its own coordinate grid. So let's say we are on zone 1. Let's just zoom into zone 1. You see now there's an extent. Right, good. So from here to here is the 6-degree wide, and then each of these zones has its own coordinate grid. So if your project area spans two zones, that means maybe zone 1 and zone 2 somewhere around there, zone 2 and zone 3 somewhere around there, 3 and 4 somewhere around there, the coordinates from each of the side won't line up because each zone has its own central meridian and false easting. So we have a case study here. Let's zoom to layer. So we have this project area which is in red. Okay, they are all in red anyway. So we have this project area which is in red, and then you can see that it cuts across two zones, zone 31 and zone 32. Right, good. So what happened? We now created 4 points, 2 on each of the zones. Right, good. So we have 2 on 31 and then we have 2 on 32. So when you go out with your GNSS receiver or whatever instrument you want to use to capture data, and then you are in a projected system, and then you acquire the data, if you are not very careful when you are crossing the zone, as we have told you earlier, the coordinates from each side won't line up because the zones have its own central meridian and false easting. So what happens? So when you realize that your project area actually cuts across two zones, then you are actually in that scenario or the condition whereby you have zone crossing. So there are a few things you can do. The first option is to maybe reproject to a single zone. You know, we have zone 32 here, we have zone 31 here, we have zone 30 here, depending on wherever your project area is. So you can decide to reproject to a single zone. However, there's a caveat to that. You know, if you reproject to a single zone, you need to keep a note, make a note so that someone who is trying to work with your map would understand that you reprojected to a single zone. But you should ensure that the zone you would use for the reprojection should contain the greater part of your project area, and most times that will not be very good. So another thing you can do is that you should use a geographic system. That's the second option. Right, good. So you use a geographic coordinate reference system which gives you the values in latitude and longitude, no longer eastings and northings that are dependent on zone if you're using the universal transverse Mercator. Now another thing to note is that if you don't want to reproject to a single zone, and then you don't also want to use the geographic coordinate reference system, you can create a custom local projection which you can use within that area. However, you should also note that there will still be distortions, because projection simply means you are transferring what is on the curved surface, which is the earth surface, onto a flat surface, and by so doing you are going to forego some stuff. Good. So aside reprojecting using the geographic coordinate reference system or trying to build a custom projection, you can get a projection system that covers the whole of your project extent, because we are using UTM, which is one of the projection systems. There are others. So depending on the area you're working on, you can decide to look out for other projection systems that can cover the whole of your project extent, just like we have for this our red boundary that covers two UTM zones. Right, good. So it is very important for you to understand that you actually, when you are working on the projected system, cannot, especially using UTM, cannot bypass zone crossing if your project area is very, very large, just like we have seen. Sometimes it might not be very large, just like you can see this other red box here, right? Good, but they are very close to to the boundary, right? Good. So you need to be very careful so that you don't take the coordinates of this to this point and the coordinates of this to this point, right? Good. Now before we leave, we are going to show you the eastern and northern coordinates of these 4 points as they are inside of their different zones. So we've done a thing now. You can see we have the composite POIS. However, we have split it into two, one that shows that in zone 31 and another that shows that in zone 32, right? Good. So we told you that we are going to display their coordinates. Good. So we have successfully gotten the eastern and the northern coordinates of those our points rather in the two zones, right? Good. So this is for zone 32, the coordinates for zone 32. Let's save that and then we stop the toggle editing. Then we come to zone 31. We also save that and then we stop the toggle editing and then let's also dock that. Good. So before we leave, we are going to import this as a CSV file and then declare the fields here to confirm that the points are actually plotting with their coordinates. Good. So we have the file here, zone 31. That's eastern is X, Y is northings, and then we take it to zone 31. So we add and then we close. So you now see that the zone 31, okay, let's change this to something completely different. You now see that the zone 31 is actually falling where zone 31 is when we plotted with the coordinates, right? Good. So we believe we have explained what zone crossing is, and then when you have zone crossing, you should be able to get the UTM zones to know the line that separates them, that's the boundary, and then you either reproject all of them to a single zone, or you use a geographic system, or you use a projected system that covers your project area, or you just separate each of them to their separate zones, you reproject them and then you later join them together. So these are some ways you can tackle zone crossing. You can leave in the comment section which of them will be easier for you, or if you have any other method that can be best used to handle zone crossing. So until we see you on the next tutorial, ensure you keep staying safe and have a fantastic time. Bye.